So the thing is that the training involves should require a huge amount of data, because every record, when you say the huge amount of data means the number of records, so it should be big numbers. Then only the different the combinations will be different, right? So then the graph can find a generic pattern. So you might be realize what I am telling you at the moment. If I immediately have to put in a diagram, so this thing is I'll do. If I have to tell you like that, so if these are the x and y axis, this is x and this is y. So our data points are, these are the data points, let's say. So we put it, and let's say only one variable. This is experience, and this is salary. This is salary, and this is experience. Sorry. So in terms of experience, what is the salary? The target variable is salary. So when the data will be small, so I don't know what graph pattern I should follow, right? So when it will grow on and grow on and grow on, then I know that, okay, if I put a line like this, most of the data comes in here, right? So more or less it is fitted. Only if I have these three variables, so I cannot find because I don't know, I don't have much knowledge about what is the requirement is, correct? So the more data is there, so fit in x and y or a z plane, it finds a pattern. So we talk in terms of 2 dimensions generally, but at the moment I have to tell you that every column that we are going to discuss, every column in a data set is actually a dimension for a machine learning algorithm to find a graph.
Okay.
So that is a different thing, right? So when you come to the gradient, so I will explain you what it is. So every column, so you might have seen. So these are all columns. So if I take out of there all features, age, tenor, and number of products, so it has to be in a one dimension, x, y. Now y is a target, let's say x, z, or p or something. But we can represent only 3 dimensions. And we talk about 2 dimensions because then we can easily plot it. But how it is how it is a many dimension you thought as, because you try to find the relationship. What is the dependency of, what is the change of y with respect to x? What is the change of y with respect to z? So that's what it will find a relationship, and that we will discuss later on. So AI, machine learning, AI is a broad higher level term, then it comes the machine learning. When you say AI, you can use all the things, let's say robotics, computer vision, so all different things. Computer vision is what? So we use a camera, we can write a small code, Python code. So that is going to use some library of OpenCV. OpenCV is a library for image classification and identification and image recognition. Image recognition and identification are 2 different things, right? Identifications mean, recognition means, what is this? It's a cat or dog. And when you say I put 3 human beings are standing in front of me, so then identifying that particular person is identification. So all these different branches will come under artificial intelligence. Whether it's speech to text, that's also we say AI, because it is reducing our job by whatever we speak, it is converting into, the speech is converted into text. Similarly, text can be converted into speech. But we don't put our effort to write this library because it requires a lot of maths inside, Fourier transform, and many other things. So that's we are not aware of. So this is a particular, again, a research area. So we use the APIs, and all other companies use. So 1 or 2 companies will develop, and other will going to use this as an API.
Okay.
So Google has bought a company API.ai. So and whatever speech to text they are using is from that startup only. Now they are enhancing that. So reinforcement is another type of machine learning. It's out of machine learning actually. It's not come under supervised and unsupervised learning. another type of algorithms. So that behave based on the actions. So let's say, I mean, the chess competition, the chess, I mean, the machine or machine can beat a person, right? Many times machine beat human being. How it is? So using neural networks and reinforcement algorithm, reinforcement will take a decision. Let's say it finds that what is the next move. It find out 3 or 4 moves can be there. The possible move is there. So out of that, which action it will take? It will take based on that. That the last the few games data is there on that. What was the best move? Let's say it has a history of say 100 games, 100 chess competition between 2 players. So it will read and find out which one is the best. What is the best pattern? What is the best move should be on the based on the 4 or 5 combinations it has. So it's actions based on the current situation. So these are, I mean, some applications I have read. So these are the different areas. So I think it's so this is saying about speech recognition system. So there are much more than that. So generally, transcript the speech to a text. So why we use Python for machine learning? So machine learning is nothing but to recognize patterns in our data, and then to know the patterns, we require load the data, clean the data, right, and apply some algorithms. So our programming effort should be less, and our logicals and our conceptual things should be. We should have a time to work on it. If you work on C++ to do the same thing, we have a tendency to do a lot of errors, right? Memory leakage or compile time error, others. The deployment mismatch will happen with the OS. So we don't want to spend our time on the other developer activities. Rather than we want a programming language which makes our program fast, efficient, and clean. And that's why we use Python as the most popular language. After our programming is coming second, and Python is the most popular from 2017. And here we are going to do this kind of steps: extract, process, clean. So these are the part of machine learning. We call the process as a data science process. So we'll explain details on that.
Okay, thank you.
So we have, I mean, we have to go through the slides so that will be more clear on it. So Python is used. Another thing is that community is very big. Around 1 lakh contributors are there who more or less used to work on bug fix from the bug fix to the more core part of the development. And will be using mostly NLTK, NumPy, and Pandas and scikit-learn. So these are the main important library provided by Python. So we call it a package. So the package in the sense it has many implementations. One package has many implementations. It might be a different class are there, right? So you are from developers background or testing background?
I'm from a developer background.
Okay.
And one question I have, Jamie, is that like whether what is best for this machine learning thing, the 64-bit Python or 32-bit Python?
Definitely 64-bit because it requires computation high. The more higher architecture you go is better. Even when you use deep learning, so if you have a GPU, because hiring a GPU is difficult, so Google provides some free for sometimes 1 month. So when you have an NVIDIA, I mean graphic processing card, graphic processing unit GPU, and it is more faster. So that is definitely will be 64-bit.
Okay, so like yeah, because like the Python which I have on my PC is 32-bit, so I think I need to upgrade that to 64-bit,
yes.
right?
Python you have to install 3.6 or 7.
Yeah, I have the 3.7, but the Python is 32-bit for me. So I think I installed
Put in the 64-bit. Your OS depend on the OS installation is what?
Windows 10.
So it is definitely 64-bit installation, right?
Yeah.
Yeah, then you can replace that. And not that required. So I will tell you in the next slide. Today only I try. So Jupyter you can install it. Anaconda.
Mm-hmm.
Anaconda prompt. This is Anaconda. I will tell you. It will
Okay.
give you a window like this.
Mm-hmm.
Like this one. So where you can type it quickly, do your program, and
Okay.
it's clearly you can quickly do the things and visualize it.
Okay, got it.
So the Pandas, scikit-learn, NumPy, and NLTK, these are some important library,
Right.
and Matplotlib and Seaborn for visualization data too. Visualization is important at some point, and it is more important in the data science perspective.
Mm-hmm.
And when you say the data science, I'll tell you there will be more role. We'll say that, and you'll be seeing some people they wanted to tell them as a data analytics, right?
Mm-hmm.
Analytics professional because they are more confident about their statistics, and they wanted to find they have a statistical background and they wanted to understand the things in a statistical way.
Okay.
And so they wanted to find a relationship and all having mostly in the graph or mostly using some statistical basics. So, but when you see coming from that only is important, then machine learning tends to solve those problems in a machine learning way. That means it uses the algorithms. So if you are not aware of that also, it doesn't make you hard. I mean,
Right.
you don't I mean, it's better to understand, but you are not going to stop because of you don't know the statistical concepts.
Mm-hmm.
And which comes from the deep learning, TensorFlow. The deep learning make your feature engineering, cleaning up activities, these are less. So we are ready to work on the text data.
Okay.
SciPy has a one library that is used that has most scientific computing, linear, exponential, I mean mathematical, exponential series or logarithm, whatever mathematics functions are there, everything is built in here, SciPy. So that is generally we don't require because still on the problem is like that, which are coming from mathematical domain, then you may require. Depends on the problem statement. And Python is also used very good for using web development using Flax and Django. So that help us to build a backend quickly.
Mm-hmm.
So when we talk about loading data and cleaning and solving by machine learning, it is the pattern is like that. We first look at a problem. When you see a data, like see if I look at this data, so immediately I require this heading because I wanted to understand what is this column talking about.
Mm-hmm.
Has credit card, this person is an active member, what is his estimated salary, is yes, and one more thing, these are all past data.
Right.
This has happened. So this we require because we wanted to train the machine learning algorithm based on this. So we wanted to understand the data first, and then we wanted to understand which one is the target. So what is the expected output, predictions.
Mm-hmm.
What is the problem statement? The problem statement will say that we want to understand the company's retention policy, retention or attrition, sorry, the company's attrition. So when you say the company's attrition, then we get to know, okay, this is the target. So this we wanted to know, this is I am going to train. And we
Okay.
have to understand these features, what is talking about, because we have to understand which features are important and which may be not necessary for our dish analysis. So it is not required. It's not mandatory that if a column is not required, we should keep it. We can remove it. Here we have removed it. We remove this column. So the question is important. Then we have to load the data. Loading the data is not a difficult thing. So loading data acquisition means acquire the data. So sometimes it may be a little bit difficult when it comes from database. Then you have to export it to Excel or CSV format. But if you see the MySQL or Array, there is options to export, right?
Right.
So you can get the data. And after that, the thing is to load it. Load it in our load it using pandas. So that's why we are going to use pandas package. So here we have used this is the pandas package. So to make your experience real time, so I'll show you. So import pandas as PD. When you do that, we are importing the pandas package, and this is what we call as an object. When you say as this one, this is the objects. We are using one objects of pandas, and then using that objects dot, if we do, we can use the method that is available inside pandas. So read CSV is used for reading a CSV file. Similarly, Excel is for used for Excel file. So at the moment you don't need to practice. This is I just wanted to match the theory with the practical. So once we load the data, next thing is the cleanup of the data. Cleanup of the data makes many sense, like remove the unwanted columns, remove the rows that have missing values for a particular data. What it makes sense when you say missing values? Let's say, for example, this field is not there, particular. So if this is not there, we have to find out some way. If we can find a mean of this, median of this value, mean of this value, because it seems a continuous data. So continuous data is what? Continuous data is something that is not, can have a defined range also, and that can be indefinite. So from 1 to infinite, it can be 1 to 1000, but it can be any number in between. So this is a continuous data. And we will have a categorical data when there is some category that is repeated.
So in this case, Jamie, the column which has male, female, that is like a discrete data, and the numbers is the continuous data, right?
Yes, yes.
Okay.
So we'll see some slide on that differentiate between the data type. So now let's say you cannot have a way to find out what we have to do it. So then we will be going to delete it, right? So delete this row. Delete this row easily should be done. So we require some methods with the help of, we can drop it. We can directly use drop now, and there are methods available in Python which we are going to use to drop it.
Okay.
You can drop the columns, as I said, or sometimes we are going to replace it. Replace it with some value. So whatever we do, there's replacement, and that we are as a part of, we say, data wrangling, replacement, cleaning, data manipulations, or data wrangling will be part. Will be whatever we are going to clean it. Might be we are going to remove it, or might be we are going to modify it. So we have to make sure the data is having not null values, and we have all categorical data is also converted. If it is not a numerical data, we should convert into numerical binary format. That will use some hot encoding method. The method is called hot encoding. So we'll see that before going to linear regression. So then we'll apply this machine learning model, and then we do the reporting. But when you do the machine learning model, is not that before that, after that only we do the visualization. Sometimes the visualization come before that. Visualization is the data exploration. We need to explore the data. Sometimes we require some actions or some data, just like we yesterday I show you something, right, on the logistic regression. So here we are not applying the algorithm. Algorithm we applied down. So algorithm we are applying here only, logistic regression.
Mhm.
But then here we are using this visualization different to understand few things. So the exploration can data, this is called data exploration. That can come before also. Before also, it's not necessary that only to show to the
Users.
stakeholders you require. It should come before also. So this is, you can read again. There's nothing is there. So ask the right question, understand, interpret in data, statistical and mathematical model apply, visualize and work as a team member. Nothing is there. So let me know, some slides are very theoretical and in case you have a preliminary knowledge, so I'll skip, otherwise I will explain it.
Okay.
So this slide is about talking about loan has been going to be approved or denied. So based on that, so as you know, the loan applications comes from the UI, web UI or apps, and that is going to somehow is going to from the UI is going to hit the server, and the server here it is showing there's a loan application portal. Which portal in the sense the loan application. This is the user, this is the UI, let's say, and there is a save in the data server. And then we have to get the data from the database and do the analytics and find out is the loan going to approve or deny. So there are two conditions. So there is a target variable approval or deny, and there may be many features. Features are the columns, as I say. So features are the different column name, and the target is that which we are going to predict. So NumPy, Pandas, scikit-learn, Matplotlib, and SciPy, these are some of the important tools. The mathematics and engineering things already built in. And NumPy is used for numerical. It's called a numerical Python. It's going to solve in a matrix calculations easy. Generally, if you do your own program, it will be very difficult to do computations within a matrix. But using NumPy, it is easy. Even we can divide a row of a data set using another row. I mean, what I mean to say that, let's say this one is, so here if I have to do, let's say these things divided by this, so only, but we can do it using general division, but if you wanted to divide the whole row, if everything is number, this row divided by this row, then using, or let's say this row divided by some value 4. So that is going to happen for the whole, all the column, all this field. This one also, this also, and this also, let's say. So like that, there are many facilities are there in NumPy. So some of the methods you will find overlap between NumPy and Pandas. And then that time you can choose any of them. It's not a problem. So basically we have to speed up the things of working, of cleaning and manipulation the thing. Use NumPy and Pandas. And the scikit-learn has all the machine learning implementations. It is a most important package is the scikit-learn, which is all the important algorithms are developed and many other techniques are there. Whatever after NumPy and Pandas task is done, we all rely on scikit-learn.
Okay.
So data wrangling is the part of which we say the cleaning and manipulate the data, and exploration is visualization, discovery and pattern. Discovery is something we visualize it and we realize something. And the pattern we find out using line graph like this. We can find out the discrimination between these two graphs. But here we see that they are having the same pattern, right? So the data wrangling might be sometimes it's very difficult because of the unexpected data format. Sometimes the data can have more error numbers, then it's very difficult because you cannot expect that everything should be good. So sometimes back I saw training, corporate training. So they are asking their data is almost 40% data is already missing, and for them it's very difficult to work on a stabilize the things with machine learning. Volume data to be the data can be very big, need to be manipulated. Classifying data to linear. So this is classifying the linear and clustered. What is that means it's not difficult, I say. The data is linear or clustered. So the problem is what? So once we understand the supervised and unsupervised learning algorithms in details, so it won't be difficult for us to categorize in what kind of problem and what algorithm you are going to use, right? So, but the main problem is the data. If it has more errors and more missing data, that we cannot help. So that is the basic things. The relationship between observation, feature, and response. Observation is what that is a record. Row numbers are known as observation. Features are already columns, and this is a target. Target is also called as response. So data exploration, model selection. Exploration means we are putting some graph and trying to find out the data, how it looks like or what it talks about. And so it can help in the overall data analysis process. Should be and accurate to that is not. I'll tell you what is important. Some of the theories are not very relevant.
Okay.
This is a completely different things. Model selection, data exploration is a part of model selection. Model selection means which machine learning library you are going to use. But then this model selection itself depend on these activities. Overall data analysis should be accurate to avoid iterations. Model selection should be accurate means what? Once you understand all the algorithms and once you understand the pros and cons of each and every algorithm, then you can find which one should be good, right? And sometimes you need to apply 2 or 3 algorithms for the same job, same data. Then you will see the accuracy, how much is done, what is the percentage of accuracy in solving the problem. What is the percentage of accuracy, what I'm saying? This data set, this person is going to survive or dead. So every time this is the data of all data. Once we train the machine learning algorithm, so it can predict. So if we ask him, at the moment it's very early to say, but you try to understand because I'm going to repeat this one, same thing. So repeat in the sense because see, once we are going to train it, that time we are going to supply all the features, that is the important features, and the target in the y-axis. But then we keep 30% of the data with us. 30% of the data for what purpose? Because we wanted to test it and we wanted to see once we train the data set, it has learned some algorithm. It has learned this to let's say with this one algorithm line. Then what we'll do, we'll put some more data. Here we'll put some more data. Let's say this row number, this one. We put this data, and we don't tell them the algorithm that about that this one is survived or dead. And what will happen? So it can either predict it is survive 1 or it can survive the 0. But if it is predicted wrongly, I mean, 30% data means, did you make, I mean, this is earlier I was speaking. So 30% data, do you know, like, let's say we have a 7 records here, right? So if I have to use any algorithm, so what I will do, keep 70% of the data, let's say. Generally, it will happen randomly. So it will take any randomly 70% data, and all the features and the target is survive. All the features will represent in X, Y, J, X, Z or some axis, and in Y, one particle will be for the survive. So once you train it, then we expect the next 30% things. That if you provide this kind of data, what is going to predict? It's going to predict 0 or 1. So if it is predicted 1, that means wrong, right? And 0 means yeah, correct.
Right.
So let's say out of 100, let's say our data is about 300 or 400 records, row numbers. Out of 300, 230 times we train it, 230 data, and 100 records say we have tested. Out of 100, it predicted 70 times correctly and 30 times wrong. Which should be 0, it's 1, and 1 should be 0, like that is predicted. So 70% right means the accuracy has gone to 70, right? 100 times is predicted, so 70 times correct. So accuracy is 70%. Does it make sense? Little bit you get you? Yeah. So
Yes.
Then, yeah. So then what we'll do, I can use another algorithms. Once I clean up the data, once I understand the data and apply all the steps, feature engineering is what is called. I did everything and I make the data correct. Everything numericals there is, and whatever need to do during our feature analysis, I did everything. So what I'm saying, you have talk about test train, right? So we will be splitting the data and we'll be using 70% algorithms to train using an algorithm. So then, because we use logistic regression, because we know that this is a binary problem, either the answer can be 0 and 1. So we know that logistic regression is an algorithm that is come to rescue, which has the capability to find yes and 0, 0 and 1, let's say 0 and 1, true and false. So I have applied it. Then I have applied on the predict using that 30% of the data. It doesn't have a predict target variable, only the other features. So that's how I'm getting some accuracy. Then again, what I can do, I can apply, I can use another algorithm. I call that and get objects, and again I do using train and test. Again I can use the train using the train data and then predict it. So then again I will get some other accuracy, right? Like this one. Here 77 I put. So then I can put a different algorithm. So then I can get a different score. So then what is giving me the best accuracy, I can take that.
Right.
So this way I have to judge. So before that we need to understand all the algorithms. Then we can understand that okay, in kind of particular problem, binary problem, there is a logistic regression. There is a naive-Bayes Bernoulli method is there. We can also solve, and if there is another is there, we can use that. And we can use neural network also for the same problem.
Okay.
So this is exploratory data analysis, what we call as a data cleaning and manipulation things. And here you'll get to know one more terminology, outliers. The focus is on the data.
Right.
Its structures It is structure, outliers, and models suggested by the data. What is outlier here? So say I have all the data in this pattern, all the data sets in like this, but I have two data where it is coming like this. Now I cannot find a graph which fit this also and this data also.
Right.
So these are outliers. So these are far away from the regular pattern. So this is going to be automatically ignored by the machine learning algorithm. So EDA technique is quantitative. EDA is data explorations. When you do the explorations, quantitative means numerical. So any analysis where it's working with the numerical data, with a percentage or any, I mean, you can measure it, then it will be quantitative. Graphics only can help you to visualize. So it uses statistical functions. So statistical functions means a bar diagram can be like the histogram plot I say, and the box plot I showed you sometime back. So this is a graphical technique. So these are graphical technique. This is a graphical technique. So what is I mean the mean, median, mode, and mean is the point which indicates centralized, right?
Right.
Okay. So let me know if you are already comfortable on this because you said you need a long time study.
Right. Means I know the mean median mode, but I'm not the PCA part means I'm not very means I've not done much work on the PCA side.
Okay, it's just it will take 1 minute.
Sure.
So the mean is the generally in the statistical terms we use that summation of the terms divided by the number of samples.
Right.
So it is helpful in continuous data. So let's say we have a missing data in a particular column and we have a continuous data. So what we can do, we can sum up all the data and divide it by the number of samples. So we get the mean. So that mean can be helpful for replacement of the missing data. Understood?
Yes.
Yeah. So then the median is the middle point, which is n by 2 and n by 2 plus 1 for even number of things. So it is odd, then the middle will come. If it is 5 sample, then the third will be the middle point. If it is even 6, then 6 number of sample are there, then third and fourth will come. So for that n by 2 and n by 2 plus 1. And median can help us in categorical data replacement.
Right.
And mode is the most frequently occurred data in any sample. So the example might be in a queue, if a person's wait for a bank to get their numbers coming. So if the most of the people are in the queue for 1 minute, then the mode will be 1. 1, 2, and 3 minutes is the queue time, then 1 will be the mode.
Okay.
This is a kind of outlier, so which is sitting away from the regular sample.
Mhm.
So how to find out the variance is like the example is like putting some dogs pictures.
Oh,
This is the height of these dogs. So mean is the summation of all divided by 5.
number.
So it is this one. And then once we get a mean 394, so we put this in the green mark. So the green line is the mean.
Okay.
So then if you put the sample's height minus mean,
Mhm.
so 390 mean minus the sample. Yeah, so it is dividing, right? So here, what is that? Yes. So sample minus mean square divided by 5. That is the variance. So 600 minus 400 like this, all calculated minus and square.
Mm.
So this is the variance. We don't need to work. And if you put the square root of this variance, this is a standard deviation.
Deviation, right.
Yeah. So the standard deviation generally it more closer to 1, the value of 1,
Mhm.
and it measures actually in the problem of regression problem.
Mm.
So how it makes sense like it more sense in the regression problem. So I'll jump into that and I'll tell you.
Mhm.
I'll come back to this slide. So I will tell you how it makes sense in our variances,
Okay.
linear regression part. Okay. So this is a line, let's say, these are the sample data blue colored, and
Mhm.
the machine learning able to find a line which goes through the middle of the many points as much as possible.
Mhm.
Looking at that, the distance, the vertical distance is minimum for every point. So this point, this distance, the point and this one distance should be minimum.
Yeah.
SSE you seen, right?
Mhm.
So this SSE should be minimum. So SSE and SSR both should be minimum. So let's say SSE should be minimum. And what is this? This is the thing is the variation. So this error, the variation, this error when it will be reduced and very less than the, you see the variation is also less.
That's right.
And when this all data points fit into exactly this line, then you will see a variance of 1.
Right.
So that's why when we do the regression problem, we wanted to make sure that our variation score is near to 1. We cannot find the accuracy in regression problem because the samples can be up and down. It cannot be said that it's a correct or wrong.
Right.
So we cannot judge in percentage, but we can judge in variation.
Okay.
So this is a plot actually showing it's a statistical actually discussion, and this is the called as a line graph, and it's showing that the pattern has been changed from this point.
Right.
So this is an exploration using visual technique, graphical technique.
Mhm.
So what is actually the hypothesis is a statistical terminology again. So hypothesis terms come from the research, where researchers, when they used to develop a patent, they used to write a test case where it says that what kind of input they should give, and the formula will give the what is the output, and then what is the actual output and should be given. What is the input should be and what is the output should be. So this is the measures of to make that the model is correct or not, or the formula is correct or not. So the same thing has been borrowed in like in statistics and machine learning. So here it is said they establish between the relationship between dependent and independent variable.
Right.
And the hypothesis building in machine learning is said that it starts in the data exploration stage, but mature in the conclusion and prediction stage. How it makes sense? Like, see, actually, if you have to remember these things, I'll tell you, this is the way you can think of it. Model building, model evaluations. Model building is what is saying. So it has three steps. Let's say model building, model evaluation, model deployment. What is model building? So feature engineering, which input variables or features are important for the kind of problem. Whatever is not required, we are going to delete that particular column. Right? So identify the right features, evaluate the model's capacity to forecast with this variable. So we wanted to understand the model or machine learning model, which model can solve this problem. So this is the analysis part you are doing. You are finding out which are the input required and which are the model is going to solve the problem. Right? So you are building means you are keeping in a frame now. Then the evaluation time you apply after you done the data exploration things, then you do the train and test the model for accuracy. We train it, then we test it for the accuracy, and if it gives into certain benchmark accuracy, then we'll say that okay, we can try this model for production.
Right.
So optimize models accuracy, performance, comparisons with other models. Compare with other models, you find the accuracy. You can find out the performance also, how much time it requires. Basically accuracy, and you can find the comparison with the other model for accuracy. So once you are confirmed, then you are going to deploy for predictions. The model for predictions. That means in the production you don't require again train, right?
Right.
So our basic fundamental is we will be supplying with a huge amount of data. We'll be cleaning up and doing the feature engineering, and we'll be applying the model, and then we'll be using it in the productions many times.
Right.
So unless it's kind of a intelligence build up and use it for our daily purpose rather than putting into our eyes, brain, everything, doing manually something.
Okay.
So if you don't apply the machine learning model, then what you have to do? Every time the new data comes, we have to find out. So then we'll be cleaning it. Then we'll be anyway. We have to do the cleanup for all the data. But then once you do it, you can automate it. But many people, what they do, I've seen in many companies. So in the productions also, every time they do manually, they take the data, they clean it, and they predict it. So every time, so that can be automated done, because see, when you do the cleaning and data manipulations, and then you create the model using your training data sets, that is the past data set. That time, you already understand that what is the best practice, right? For this kind of data. So you can automate the same stuff for your deployment.
Right.
You don't need to look at the data again and again.
Yes, I get it. Because that will bring up the efficiency.
Yes. So that is the replacement of the human, right? So when
Yes.
half of the things are manual, then what is makes sense? So this is a slide talking about measure of hypothesis testing with confusion matrix.
Right.
1 minute, so some water.
Okay, that's fine.
So the measure of hypothesis testing. You are here, right?
Yes, I'm here.
So this is what the diagram you can see is called confusion matrix,
Right.
and the use of it is to find out the accuracy actually. And the basic formula, and this is a measure of hypothesis testing. So how to hypothesis testing, then how much we predicted correctly, how much, let's say in a binary problem, what will happen? So there is it will be 1 or 0. If this is a past data, we already have a result, right? In a medical record, let's say the doctor has told that the patient has diabetes, and also the predicted the machine learning algorithm is predicted as a diabetes is there. So then it's correct prediction. So the again the doctor told that the particular patient has no diabetes, and in the prediction also there is no. So these things.
Right.
So this is the correct prediction. So actually no, actual no is the past data, and predictions also no. And this is also correct data.
Right.
So this diagonal we are representing is the correct prediction. So 150 samples out of 165 patient has been treated with a disease, and our predictions based on the machine learning algorithm, it says the 150 correct out of 160.
Yes.
And this is wrong.
Yes.
So you can find out directly the accuracy using 110 times correct. So 110, 150 divided by 165 into 100. And that will give you percentage accuracy, correct?
Right.
The same thing is written here.
Right.
The true positive. So this is also known as true positive, true negative, false positive, and false negative. So which one is I have represented here? See, this is called true positive,
Right.
and this is true negative. Both are true. This is for positive term, positive sense. This is negative sense.
Right.
This is false in a negative sense, and
Yes.
false
All
in a
positive.
positive sense. So when we plot the data for using matplotlib, we are going to deal with numerical, categorical, time series data.
Mm-hmm.
So numerical data, will be like a discrete data, right? So this, we can have a counting number of employees in a company. So these are this numerical data, the continuous data value with a range that can be measured. So both are numerical. And then cluster or group categorical data can be, we can say the cluster data. There's a group where values tall, medium, and short. These are groups. Ordinal group values as per rank. Agree, strongly agree. So I have a. If you wanted to have a more details on this data kind of things, I have a statistical document also. I don't want to go all these things.
Sure, definitely.
But if you require, I can give you that. You can check on the data types. So some might be asking if you go for interview, if it is just more on the data analytics role, then they can ask you more on this kind of data and examples and other things. But whatever required.
If you have the, as you mentioned, you have the document, you can send me the document and I'll go over it.
Okay, sure. For a statistical analysis, I have separate documents that is supplied by somebody else.
Okay.
That is a statistical analysis actually, more on the statistical part, not the machine learning.
Okay. Yeah, send me those documents, I will review it.
And there can be time series data. So it is the measures of time. So major category of statistics is inferential method and descriptive method. These are the higher level terminology for statistics. So descriptive, you already know that it's to record the height of each and every person. So we can measure it, right? Tallest, shortest, or average height of the population. So this we already have gone through it.
Right.
So in the data distribution, so in the statistics, in statistical terminology, they used to look at the data distribution. So the data distribution says that the data which is more common data will come into the middle part. So this is the middle part. So here most of the data should be here. So and when the data are normal distributions, distributed normally, I mean more data are normally distributed in the sense that data are more closer. So then you get a hill high. And when you get the data are not distributed uniformly, so you will get a flat hill.
Right.
So that is because this is called a central tendency that indicates the accumulation towards the middle of the distribution.
Okay, right.
Frequency indicates number of occurrence of a data value. So this is the frequency. It will be a frequency. This, if I put a like a bar diagram like this, it will indicate the frequency.
Right.
And range refer to the minimum and maximum value. This is the minimum is minus 0.3, minus 3, and this is 3.
Right.
So this is one diagram we represent. We say that 90. If your data is evenly distributed, you will come up with a bell curve. That is the shape of the bell. When data are uniformly distributed, then you will see a hill like that, a bell curve, look like a bell. A bell curve has a small percentage of data points on both tails and bigger percentage on the inner part of the curve.
Right.
So the diagram represents 5% of the data would fall into the tails and 90% in between.
Right, exactly.
So we represent like this. So this tail represent little bit of data, and you can also interpret like this. That let's say in a school in a class, all the people, 90% people or 95% people got a marks of 70, around 70 to 80%. So
Right.
we'll fall in the middle, and if somebody got 30% or somebody got 90%, will go into this and this part.
These tails, right.
So this way, the bell curve will be created. So this is the Anaconda package. We are going to use it for in our Windows system. So did you use Windows? Windows, right?
Windows, yes, yes.
So it's an open source Python distribution, and many other packages required for machine learning. It's already in a one shot installation we can have.
So Jamie, like I had installed my Python without Anaconda earlier, and anyway, it is 32-bit, so I can remove my 32-bit installation, then use Anaconda from the start, right?
Yeah, you can do it, and at the moment you don't, you can directly install it. So go to this link,
Mm-hmm.
anaconda.com download, and keep the
Yes.
download. So it will take a few minutes.
10 minutes, okay.
This downloading.
No, I'm just trying to remove my Python.
Okay, I think only yeah, removal may not require because it will go into one directory and you will give the path. It will take automatically.
But like I wanted to get the 64-bit Python, right? So, so like if I download Anaconda with now, whether it will use my 32-bit or it will install the new 64-bit.
It will. There is two options is there. I remember. So you can go for the 64-bit.
Okay. Okay.
So
One second.
yeah. One thing, let me think on your old installation. Sometimes in systems it create problem later on few things.
Mhm.
Uh, Old installations, how it is it an installation is there? How what are you doing? You're directly deleting it.
Means what I was trying to do is that go to the control panel, add a remove programs, and try to remove it.
But is it showing in a control panel?
Yeah, it is showing in the control panel. Yes.
Okay, then it's good.
Okay.
Because otherwise proper uninstallation will not happen. Okay, so yeah.
Or you can continue. I can. Or do you want me to do it right now, or I can do it
No,
later?
no, okay, now I thought just you will be clicking that, the download will happen. So by the time
Yeah,
class is over, that you will be installation will be ready.
that's fine. I can do it after the class.
Okay.
But
So
like I should be using Anaconda to get the 64-bit and everything. Yeah,
yes,
that should happen. And that will include all the NumPy, Skype, because I install all
yes,
those packages manually.
yes,
So
everything will be there.
yeah, when I do Anaconda, then I don't need to do it manually. Okay.
Yeah. So yeah, separate packages you can only, yeah, later on you can do it. No issue.
Okay.
So this Python will have. So did you? I mean, are you doing any Python work earlier, or in the for machine learning
Yeah,
only?
yeah. I mean, so I have done some Python work. Like I have done Python. I have used NumPy and Pandas, but I have not used like Skykit. I have not used the skitlearn and all those things.
Yeah, but in general Python. Okay, so just I will be explaining quick. So there are two types is there, and the numeric data types will have an integer or float,
Mm-hmm.
and 32 or 64 bit data type will be based on the OS.
Yes.
So and in Python, you have seen we don't have to declare the data type like other high-level programming
Right.
language. We have to only mention we have to initialize it. Once it is automatically understand that this is a float type,
Right.
this is an integer. Also, it has a string data type, which can be you can include in single quotes, double quotes, and three quotes.
Right.
So there is a basic data type also is called null. So
Right.
null data type. So is mentioned using none. So that is nothing is there. You don't want, let's say you don't want it to initialize with some value, so you put it none.
Right.
So is none is doing to check that this is none or not none.
And,
So you put a 10, definitely is false,
mm-hmm.
right? So other way it is true. This is true because it's null. So once you done it, so yeah, once you install the Anaconda, what you are going to do is
Mm-hmm.
so I'm putting Control C and killing it
Mm-hmm.
because once I run it, so it's running unless I stop it. So you need to find out this one directly. You can click it, and sometimes in the command prompt also is make fast.
Right.
So this is Jupyter notebook.
Mm.
So Anaconda prompt, sorry, it is one. So navigator also Anaconda, navigator or prompt. So both you can click. So
Okay.
it takes sometimes time. So if you put in click on this one, it will come
Mm-hmm.
quickly.
Okay.
And then you have to type JUPYT Jupyter notebook.
Okay.
So it started. This is the,
Right.
it automatically open the browser also. Or
Right.
else you can, yeah, it's automatically open only. Or you can copy the link and open it.
Okay.
It's opened it, right? It's opening this one new. So this is the new browser open. So after that, you can go new. You can note down this one if you do. So Python 3.
3. Okay.
It will automatically come based on your installation.
Mm-hmm.
These are all dead now. So because I have closed the terminal.
Okay.
Let me paste it otherwise. So this is the, now here you can do anything. You can run it like this.
Right.
Even if you can write a method also.
So this means the Jupyter gives like much more like interactive GUI based.
GUI based and visibility is good, so you can. So these are all small assignment. You can check it.
Okay. Perfect. I will.
So I think we have started 4:10, right? So we'll continue 10 minutes more.
Sure.
So generally, I'll be giving 1.5 hours.
Sure.
So this is a data type float. So it is a float type we mentioned, and this is a typecast. So you can put a typecast using, like within the
Yes.
bracket, you can put it. Or str is convert into string from the
Sure.
floating point.
Right.
So there are a few data structures like tuples, list, dictionary. So which helps grouping data set, many data of different data
Right.
types, and we can group it. So tuples is one such as, and which is immutable. That means we cannot modify once we declare it.
Declare it. Right. Yeah, that I know.
Yeah, so okay, so this is tuples. We declared it in this bracket. So what's it? And this is the indexing start with 0.
Yeah.
This is 0. This is fast. Right? So first one is when you say first tuples 1, and we try to modify it because it's a jack, and we try to modify it using mark. So it's we're getting error, right?
Right.
So accessing, we have options from the first also. This is 0 index, first index, and this is second index. And minus starts from this one. We can also traverse -1, -2, -3. So list is one-dimensional. It's called one-dimensional because it's a one only row, right? And mutable, so we can change it, and it also have many different data types it cannot.
Right.
So the methods we can use in append to add it at the end. Append remove is going to
Right.
find and remove that particular thing. So mark is removed. And pop is another way to remove it by index. And then insert at the position the value.
Right.
And the slicing works same. Slicing is for sorry, this is tuple slide. Slicing for tuples and this is same. Already might be knowing. 1 4 means 1,
Yes.
2 3
2,
4.
3.
4 minus 1. Right?
Yes.
So inclusive of the first and exclusive of the second.
Second. Yes.
The slicing of the list also same. And there's a dictionary which stores data as a key and value. So key cannot be modified because key is to hold the numbers. Using
Right.
key, we are going to access the value. So dictionary is a concept of hashing. So we put some value is there, what is the index to quickly get into the value. We go to the index of the key.
Right.
So you can define, modify, view, and lookup.
Lookup, yeah.
So we always store the value as a key and value. We need to store as the key and value, key and value. And the value
Right.
itself is again a dictionary.
Okay.
Sorry, list of elements.
Right.
So do dot keys means all the keys will return. Dot values means all the values will be returned.
Right.
So accessing is by key we are getting this value.
Right.
ID we are getting this one. And update is trying to modify the value, not the key.
Based on the key to update.
Yeah, based on the key is the same only. ID is there. So this is the value. So value you can modify it. And ID we cannot do modify, but we can delete. We can delete it. We can remove it from the dictionary. So when you are going to remove it, the ID, that means we are going to remove the key and value both, right? And set is another data structures, unordered collection of unique elements. So if you put duplicate elements, it will be only one will be printed.
Right.
And it's sorted out.
Yeah.
And you can look at this slide. So this is in operator. So this nick in this is true. Nick is this present, so it's true.
True.
Marking student is false.
False.
Word in encyclopedia.
String.
Word is in encyclopedia is one string. Then T in the word false, and I word true. So the plus operator produce a new tuple list or string. So basically to concat two different data types, not only the numbers but strings and tuples and lists also we can use operators. So here we are adding these two tuples. We'll be adding the second one after the first one. And this is two lists. We are adding again, it will be concat after the second first one. And adding to numbers, we always use this in other languages also, other programming also. We can concat two numbers, names also. This is a basic method how to write method in Python. So parameters should be named, many arguments it can take. The value is supplied, whatever is it's a string, we can put the numbers also, whatever you want. And Python expects all methods should return a value. Right? So generally it expects all return something. So if you don't return anything, this ultimately is not going to give you error.
Right.
So, okay, we'll keep it up here. So, this again a built-in sequence, new thing started.
Right. So like Jamie, like send me those stats notes which you mentioned, and when we'll have our next class and what we will cover in that next class.
Yeah. Next slide. Yeah. So, do you want me to? You can go through it if you can have it. You can see it. I'll skip this numpy one, numpy and this one.
Yeah, that I can cover on my own. If I have any questions, I will get back to you on this one.
So, basically, as you say it, you wanted to cover up. So, what I will do? I will cover up in quick. So, I will try. I will cover the numpy pandas and hot encoding by next class.
Mm-hmm.
So,
In
because there
next
is,
class, okay.
yeah. So, how many? So, there is not much is there. So, numpy pandas, I will go quick and
Yes,
pandas has many example in it. So, I will go to the important one. Then after that, I will give you a sheet. Numpy
right.
and pandas. So that sheet again you do check, and then anything is there you can ask me on that. So
Yeah, definitely.
I go through that sheet also here only, but to speed up something. So so next class will be I will be covering numpy and pandas.
Okay,
Yeah. So from this
that's
only we'll be doing. After that I will send you the sheet.
okay. That's fine.
Yeah. Yeah.
So like Nampi, so the next class we're having when tomorrow or on Saturday?
Yeah. No, this week will take. I mean continuous because from next week's new batch will start in the alternate.
Okay,
So
okay.
tomorrow you're free?
Yeah, I'm free. Yes.
Okay. So these days because then we have to tie up with the other guys, right? So,
Right.
so yeah, we'll take tomorrow. Then day after Saturday, if possible, then we'll take Saturday also.
Yeah, I can take Saturday. On Saturday we can do it around like 6:30 your time.
Afternoon.
Yeah, evening 6:30 p.m. Yes.
That will be little difficult. So I've been occupied actually
Mm-hmm.
6:30 to 9. So 6:30 to 9 I occupied. So morning, you night, other timing is there for you?
Because like on Saturday, like I go to some other places in the morning, so
Uh,
that's why like if you if means tell me like
no worry, do one thing. Tomorrow we'll take.
or
Then
tomorrow what
Monday,
we can do if you can take Saturday morning, so I can take Saturday morning also.
tomorrow you can want to take morning.
So like tomorrow, no. So tomorrow like Friday evening I can take your time,
Yes.
okay, and Saturday morning your time I can take it.
You can take, right? What time? Saturday morning Indian time.
Uh, uh, Saturday morning, 1 second, let me see. What time do you means you can do it early in the morning? Means for because for me that will be evening, so I can take 6 o'clock, 6:30, 7 o'clock.
Okay, okay. Okay, you don't have, yeah. So I have some, yeah, other commitments. So 10 o'clock is, 10:30 is fine for you.
10:30 morning, right?
Yes,
Saturday. Okay, yeah, that means that will be 9 p.m. my time. I can do it.
you can do, right? Or 10:30 or like then 11 o'clock I'll do if you know I have problem. So 9:30 to 11 will do. Your
Yeah,
timing.
that's fine. I can do it.
Fine, right? So yeah, Saturday 11 a.m. will do.
Yeah.
And tomorrow same time.
So like tomorrow, like Friday at 4 p.m. your time, I will log in, which is
Yes.
same time as today. And then in the evening around like 9 p.m. your time, I will log in.
No, no, no. Tomorrow same time and Saturday 11 a.m. Indian time.
Yeah, 11 a.m. Yeah, I got confused. Yeah, 11 a.m. India time. Yes, that's
Yeah,
true.
yeah.
Yes.
Oh,
Okay.
okay then.
And I'll go through this material also. I will review it. Okay.
Yes, sure. Okay
Okay.
then. See
Thank
you.
you so much.
Yeah, see you. Bye.
Bye.